Steve Weiland, an enterprise architect with a focus on bringing people, processes, and technologies together. Welcome to video training about IT stuff. In this digital information age, it is important that everyone has some understanding of data and cloud technologies. It is my mission to provide a baseline of data and cloud fluency to non-IT persons. This digital fluency video tells the story of data. For maximum benefit, we suggest watching this video in full screen. Data is the second most important asset of any organization, right behind the most important asset, which is you. So before we can learn about the many different ways in which we can manage, govern, manipulate, and retrieve data, we need to understand what data is and how it's stored. This video is designed to give you a working knowledge of both. To accomplish this objective, we're going to present this video to you in 8 scenes. In Scene 1, we'll talk about the types of data. In Scene 2, how we store structured data. In 3, what a database looks like under the hood. Scene 4 is a discussion of what a data warehouse is. And then we'll take a look at the difference between data and information. Next, we'll examine how we store unstructured and semi-structured data, which will lead us to a discussion of data lakes. Finally, in Scene 8, we'll talk about data lakehouses. At the end of the video, we'll recap and summarize what we've presented. We'll also give you information on how you can provide both positive and negative feedback to us. Data are individual items, often numeric or text. More technically, data are a set of values about objects, like the month object. Values can be January, February, and so on. Or they can be numeric, like 1, 2, 3, etc. The days in a month object, values can be 1 to 31, depending on the month. And the year object, 4 integers from 1 to 2021 and beyond. Then there's the salary object, SSN object, name object, street address object. You get the idea. There are many different types of data, like integers, characters, strings of characters, timestamps, floating point numbers, binary, the stuff we can't read with our eyes, like music, images, and videos, and lots of other data types. Which brings us to information, which is processed or summarized data, or a group of data that collectively carries a logical meaning. Information depends on data. However, data doesn't depend on information because it usually is used to generate information. Take a person's age, where we take the date of birth data object, subtract it from today's date data object, and generate the piece of information we call age. This also demonstrates why we store data and generate information. You see, data can change frequently, so the information would have to be regenerated frequently. Instead, we generate that information only when the consumer needs it. That saves us tons of storage space and computer processing cycles. However, there are exceptions to this, as you will see later on. There are 3 structures of data: structured data, unstructured data, and semi-structured data. Some think there's a 4th structure, called quasi-structured, but I have no idea what that means. Structured data can be displayed in rows and columns. It can be stored in relational databases, which we'll explain to you later in this video. And it usually consists of data like numbers, dates, and strings of characters. Unstructured data cannot be displayed in rows and columns, nor can it be stored in relational databases. It often contains things like images, audio, video, and binary data. Oh, and even word processing and spreadsheet files. Semi-structured data also cannot be displayed in rows and columns. It also cannot be stored in relational databases. It does, however, contain tags and other markers to separate its elements and enforce hierarchies of records and fields within the data. Semi-structured data often contains things like XML or other markup languages like HTML and JSON. binary executables, and TCP/IP packets. And it even contains emails, zip files, and web pages. So how do we store structured data? Well, in the older days, we used to put the data on paper. Then we learned to group the documents into file folders. And then we learned how to organize those into file cabinets. Creating reports and analytics was very time-consuming because you had to pull lots of documents and then cross-reference them with other documents. In the digital age, we pretty much do the same, except that we digitize the data into electronic files, also called flat files, and then we store those in a computer. Technically, it's on a disk drive in the computer. Those digital files often look like this, where they contain text, like A to Z, numbers, and special characters. And where each field of data is separated by some special character that denotes a field separator. Common field separators are a pipe symbol or a comma. Yes, there are ways of handling it if that field separator occurs as part of the field of data. Commas often have that problem. Now, if we have lots and lots of data files, we store the file data in a relational database, often in the cloud. By the way, you might want to check out some of our cloud videos. Anyway, here's what a relational database looks like under the hood. A relational database consists of tables, where each table contains a logical grouping of data. Take the customer table. It contains data about all of the customers. For each customer, we have a unique ID, their name, date of birth, address, phone number, and so on. The orders table contains data about all of the orders we have on file. In addition to data about the order, each order also contains the customer ID. That way, we can tell which customer the order belongs to. Similarly, the line items table contains data about each line item of all of the orders, like quantity. Note the order number, so that we can tell which order the line item belongs to. Note also the product ID, so we can look that up on the products table to fetch the data about the product that was sold on that line item. The products table contains data about all of the products we sell, like the name, description, and price. The product ID is unique and is used to connect the product to the line items table so that we can retrieve the product data. Finally, the payments table contains data about all the payments that customers have made to us, like the date of the payment and the amount of money that was paid. This table also contains a customer ID so that we can figure out which customer made that payment. The payment ID is unique to each payment in order to give each payment a way to uniquely identify it. They are called tables because a table consists of rows and columns of data. Each row consists of one or more fields of data. Each field is really called a column, but a lot of us still call them fields because that's how we referred to an item of data when we only had flat files and no databases yet. So the structure of a table resembles that of a spreadsheet with its rows and columns. When I first learned this, I found this confusing. So to help you understand that terminology better as it relates to database tables, let's look at a different view. From this view, you can clearly see that each column represents a data element for each customer, and a row represents all of the columns belonging to a single customer. We establish relationships between tables by designating certain columns as key columns, and then linking the two tables via those columns. You can take Carol's customer ID from the customers table and use it to fetch all of her rows or payments from the payments table. So if we know Carol's customer ID from the customers table, we can go to the orders table and fetch all of her orders, one row for each order. For each of her orders, we can then take each order number and go to the line items table and fetch each of her orders' line items. You can take the product ID in each line item row and use it to look up the item's name, description, and price in the products table. I think it's time for an intermission. I recommend that you get up and stretch, take a walk, take a bio break, get a snack and a beverage, take a nap. When you're ready to come back, please fire up the next video in this series. I promise to wait patiently, no matter how long you take. See you later.